In today's video, we're going to cover how the electric motor works. As we've seen in previous videos, if we place a current-carrying wire into a magnetic field, then that wire will experience a force. And we call this concept the motor effect. The direction of the force, though, will depend on the directions of the magnetic field and the current. And remember that we can figure it out using Fleming's left-hand rule. So because the current here is coming out of the page towards us, and the magnetic field is going to the right, this wire will experience an upwards force. If we take another wire though, with the current flowing in the opposite direction, then the force it experiences will also be in the opposite direction, so downwards this time. Now imagine instead that the two wires are connected at the far end, so we effectively have a coil, with the current flowing in from the positive terminal on the right, going all the way around the coil, and flowing out to the negative terminal on the left. Because the left side of our coil experiences an upwards force, and the right side experiences a downwards force, our coil will start to spin clockwise. Once the coil's rotated by 180 degrees though, you can see that the current is actually travelling in the opposite direction. And this means that the forces acting on each side of the coil have also swapped direction. So this left side is now experiencing a downwards force, and the right one is experiencing an upwards force. Overall, this means that the coil will now start turning anti-clockwise instead, and flip right back over to where it started. This means that if we left it like this, the coil would just keep flipping back and forth on itself as the forces kept swapping around. It wouldn't ever turn around 360 degrees, and so it wouldn't be very useful. To fix this, we need to change the direction of the current every half turn, so that the direction of the forces will always be acting clockwise, and the coil will then continue to rotate in that same direction. To achieve this, we use this weird device, which we call a split ring commutator. For your exam, what you'll be expected to know is that it swaps the positive and negative connections every half turn, so that the direction of the current also swaps every half turn. And this means that the forces acting on the coil will always be acting in the same direction, which importantly means that the coil will rotate in the same direction all the time. To see what we mean, let's take a look at the whole thing in action. If we attach the positive terminal to this side of the commutator, and the negative one to this side, the current will flow in from the positive, go all the way around the coil, and flow out of the negative one. This means that the coil will experience clockwise forces and begin to rotate, moving the split ring commutator around with it. The positive and negative terminals, though, stay where they are, which ensures that the current always flows round in the same direction. Now, although this might seem a bit complicated, in terms of engineering, it's relatively simple. However, it's still used in almost all the motors that you see, from fans to vehicles to hard drives. And it all rests on the idea that we can create a spinning motion using electricity. Of course though, in real life, most motors would have to be a lot more powerful than this one. Which is fine, because we can increase the speed of the rotations in a few different ways. One is to increase the current that's passing through the wire. Two is to add more turns to the coil. And third, we can increase the magnetic flux density by using more powerful magnets.